Okay, today I'm going to talk to you about Sankey diagrams. Now all a Sankey diagram is, it's a way of showing the energy efficiency when we have an energy transfer taking place. So the example that we're going to do is just imagine we have this light bulb. So here's this light bulb and it's obviously giving out light like that. Now let's say I supplied this light bulb with 100 joules of energy. Now not 100% of that is going to be converted to light because no device is 100% efficient. There's always going to be some kind of wasted energy. So let's imagine 20 joules of this was given out as light, but 80 joules was lost to the thermal store. So we can see that this isn't very energy efficient. Now all a Sankey diagram does and operates is just to show this in a visual way, just to show this as a diagram. Now, the thing that I always start off with a Sankey diagram is my input energy, the amount of energy I put into the device. In this case, it was 100 joules. Now, when you do this, you normally have graph paper, but graph paper doesn't show up very well on the camera, so I'm just going to use this plain paper here. So, I've got to think of a decent scale. Because if I want to show 100, obviously I haven't got 100 centimetres on this ruler, so I'm going to have to think of a good scale. So what I'm actually going to do is 1 centimetre on my Sankey diagram is going to represent 10 joules. So then when I draw my line here, it's going to be 10 centimetres long. So that's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 joules. So I've started with my input energy, okay? Now, the thing with a Sankey diagram is it really doesn't matter how far the arrows go. It's all just about the width of them. So all I'm going to do is I'm just going to draw maybe about 10 centimetres top and bottom. And you'll see why in a minute. It really doesn't matter how far these go as long as they're level with each other at this point, okay? Now, at this point here, they are going to branch off. Our useful energy is going to go that way and our wasted energy is going to droop down. So if my useful energy, my light, that's the thing I actually want out of my device, is 20 joules, and each centimetre is 10 joules, the thickness of this line is going to be 2 centimetres. So this is the bit that's important, the thickness of that. That is 2 centimetres, which represents 20 joules. I'm then going to draw that going forwards a bit. Again, the length does not matter. I'm not even bothering to measure it with my ruler. The length does not matter here. It's only the width that matters. So that is my useful energy. That is my 20 joules of light. Now, the 80 joules, I don't want that thermal energy. That's not something that I'm desired from this light bulb. So I'm going to draw this drooping down. Now, because it's 80 joules, it should be 8 centimetres wide. So there we have it. Now this is how we do it. So from this point, we should do the arrow that's going to come down like this and split like that. So can we see they've branched off at the same point, but apart from that, it doesn't really matter. The useful one usually or nearly always goes that way, and the wasted one droops down like this. So a wasted one is 80 joules thermal store. So we can see it's all about the thickness of the arrows at the point at which they branch off from each other. So here I have my 100 joules, that's my input. Then 20 joules is converted to light, which is my useful energy. That's why it's going that way. 80 joules lost to or wasted to the thermal store, so it goes down like this. And that's basically how to do a Sankey diagram. Thank you.